Good morning, students. In the previous video session, we have discussed about the equipotential surface and the properties of equipotential surface, then the relation between electric field and the potential. All these three questions are very important from this topic. So you can go through that. I believe that you are gone through and take a notes on that. Now today we are going to discuss a new topic. It is electrostatic potential energy for collection of point charges. Now you can see if you are keeping some point charges, collection of point charges, not one charge, many charges we are placing in some arrangement and what will happen? What is the effect of this electrostatic potential energy? We can see. For that, consider a unit charge, okay? One charge Q1 is kept at a point. Now you know that one charge is kept at a point means what will happen? Yeah, there will be electric field lines over this and suppose this is a charge and at a distance r you can see that maybe this point what will be there, electrostatic potential will be there. So we know that how much electrostatic potential will be there. V is equal to 1 by 4 pi epsilon 0 q by r. So now we are studying about electrostatic potential energy for collection of point charge, not for only one charge. Like this, many charges we are keeping nearby and we are finding the effect of this electrostatic potential energy. So I told that if we are keeping a charge at a distance r, what we can see? Electrostatic potential. So electrostatic potential at this point we can tell what V is equal to 1 by 4 pi epsilon 0 q by r. Suppose here q1 means here what we can tell, q1 by r. So like that this is what while explaining the equipotential surface I told. From this, at a distance r, at a distance r, at a distance r, at a distance r, any point the electrostatic potential at a distance r will be same. This is what last class I told. Now from that I am taking one charge q1 is kept at a distance r, so that the electrostatic potential at a point at a distance r from point charge q1 is given by what? V is equal to 1 by 4 pi epsilon 0 q1 by r. Okay, this you can take equation number 1. Now you see this potential. What is this? This is a potential at the this point at a distance r, and this potential this potential is used to bring this point charge from maybe somewhere infinity we can keep from some place, maybe from here. From some infinity part we are bringing a positive unitive charge, and for that some work done is did. That work done is equal to what? This potential V is equal to 1 by 4 pi epsilon 0 q1 by r. So this potential V is the work done for what? We are bringing this unit charge q1 from infinity to one point. Now you see I am keeping this q1 at a point. This point now q1 is there means I brought this charge from infinity by using what? Some work done. So I did some work. That work done is equal to what? This V is equal to 1 by 4 pi epsilon 0 q1 by r. Now you see already one charge is there. Now you are bringing another charge. Now you are bringing another charge Q2 at a distance R from Q1. Now you see here Q1 is there. At a distance R, what is there? Potential is there. V is equal to 1 by 4 pi epsilon 0 Q1 by R. And this potential is equal to the work done to bring this Q1 at this point. Now you see, now bringing another Q2 at this place, Q2. Okay, so that now you see this Q2 is bringing nearby this Q1 at a distance R. So that what happened means, now to bring, you see already there is a charge Q1 here. You know that if there is a charge, there must be an electric force. So against this electric force, we are bringing another positive charge. You know, positive always repel, isn't it? So again, when we are bringing this positive charge, unit positive charge Q2 at this point at a distance R, means we have did some work. That work done is equal to this water electrostatic potential at this point. That means this V is equal to 1 by 4 pi epsilon 0 Q1 by R, and so that you can write this work done is the product of Q2 and electric potential at that point. Understand what I said? You see already there is a charge Q1. We are bringing another charge Q2 from somewhere to this point. When we are bringing this point, some work has to be done to bring against this force, against this electric force. No, here there is an electric force. So against this electric force, I am keeping this Q2 here at a distance R, means what? Some work has to be done, and that work done is what? Equal to the product of this charge Q2 and its potential, electrostatic potential. So that you can write an equation, W is equal to Q2V. This you can keep equation 2. So work done is equal to the product of the charge Q2 and electrostatic potential at that point, 1 by 4 pi epsilon 0 Q1 by R. Now you can write this equation, substitute 1 in 2. So that what we will get, W is equal to Q2, instead of this V, substitute this one into 1 by 4 pi epsilon 0 Q1 by R. So that you can write this equation, W is equal to 1 by 4 pi epsilon 0 I am taking. So Q1 Q2 by R. Now this work done is equal to what? This work done only we can tell that we are studying about what? Electrostatic potential energy. So this work done is equal to the electrostatic potential energy. In 11th grade also we studied the same thing. Work done is equal to the stored potential energy. U you can write. So U is equal to this work done. So that you can write W U is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R. This you can keep equation number 3. Equation number 3. So now you see, you got on equation 3. So this equation is the electrostatic potential energy, and this equation shows that electrostatic potential energy is depending upon only on the distance between these two charges. So this is what the Q1 Q2 divided by R. So this electrostatic potential energy is depending upon what? Distance between these two charges. Now assume that like that same. Now 3 charges kept. You can keep here 1 point, here 1 point, here 1 point. A, B, C, and here charge Q1, Q2, Q3. Now you see on these three charges are arranged in a configuration, and for this configuration what will be the stored electrostatic potential energy. That is what this derivation, it is a 5-mark question. So electrostatic potential energy for collection of point charge. So this is a collection of point charge. This distance we can keep R12, 1, 2. This distance we can keep R2, 3. This distance we can keep R1, 3. Okay. Now you see, by using this diagram, some things you have to explain. The first thing is, to bring this charge Q1 from infinity, there is no need of any work. Assume that there is nothing here. Now you are bringing on Q1 charge from somewhere, and for that somewhere to the point A. So to bring this charge at this point A, there is no work is required. But because why? What is the reason? The reason is there is no other charges nearby. Only you are bringing a charge Q1 at the point of space A. So there is no other charges nearby to exert an electric force, so that no work is required. Now assume that you are bringing that is the second point, you are bringing the charge Q2. Now you are bringing the charge Q2 at the point B. So there must be some work has to be done against the electric field which is created by this charge Q1. Understand what I said? You see, first we are bringing the charge Q1 at the point of space A, but no work is required because there is no other charges nearby to exert this electric force. But now I am bringing this charge Q2 nearby this Q1 at a distance R12. Now I am bringing this Q2 at the point B, means here some electric force is there. Against this electric field I am bringing this charge. So some work has to be done to move this charge Q2 at the point at the point B at a distance R12 at Q or no. So that work done is how much? That is what I am writing here. So that work done is, we can write W is equal to Q2V1B. What is this work done? You see, W is equal to Q2, product of the charge Q2 and V1B. V1B means what? V1B means the electrostatic potential due to the charge Q1 at a point B. So V1B means what? Electrostatic potential at the point B due to this Q1. So here some electrostatic potential is there at this point. It is due to the charge Q1 at the point where B. So we can write that equation. What we can write? U. So this is our work done. So we can write the electrostatic potential energy U is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12. You know how you got this equation? This work done is equal to what? Electrostatic potential energy at this. So this work done is equal to the product of the charge Q2 and the electrostatic potential at the point B. Now this work done we can write W is equal to what? Q2 into V1B. Electrostatic potential at the point B is what? 1 by 4 pi epsilon 0 Q1 by R, and the distance is what? Distance is what? R12. R12. So R12 I am writing here. Now you see this equation only we can write W is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12. And this work done is equal to the stored potential energy U is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12. This I can keep equation number 4. This I am keeping equation number 4. Now you see, again you can go to this diagram. Now you see, from the charge Q1 some electric field is there. From the charge Q2 some electric field is there. So against these two electric force from the charge Q1 and Q2, I have to bring another charge Q3 at the point C. So understand what I am saying. You see, the first thing is no one is there. I am bringing Q1, no work is done. So one equation. Now the second thing is Q1 is there. I am bringing Q2 nearby this Q1 at the point B. So this electric force will be there. Now I am bringing another charge at the point, another charge Q3 at the point C. Now you see, here electric force, here also electric force is acting. So that you see, now work done is what? Work done is done. Some work is done to bring this charge Q3 at this point, means that is what? Against this force and against this force. So what we can take is, we have to find the total electric field between these two charges. So we are bringing this charge Q3 against this total electric force. From this side also force is there, this side also force is there. So if we are taking all together this total force against this, we are bringing the charge Q3 over here at the point C. So the work done we can write is, so we can write the work done, we can write W is equal to, we are bringing the charge Q3 and the potential, you see from where and all potential is acting? Potential is acting from the charge Q1 at the point C. Now plus this is the total electrostatic potential. Potential is acting from the charge 2 Q2 at the point C. You see, from here due to this charge there is a potential acting at this point. Due to this charge there is an electrostatic potential acting this point. And what is this potential? What is this potential? So now let us find this Q3 potential at the point 1. So Q1, so 1 by 4 pi epsilon 0 Q1 by 1 over C. 1 over C means 1 over C. So the distance is R13. Now plus potential at point 2, 1 by 4 pi epsilon 0 0.2 Q2 divided by 2C. 2C means at the point 2 over C. So the distance is R23. R23. Now I am writing this equation. W is equal to 1 by 4 pi epsilon 0 I am taking outside and this Q3 I am multiplying inside. So Q1 Q3 by R13 plus again multiply this Q3 here, Q2 Q3 by R23. Okay, so now you go to this equation. This equation you can keep it as what are? This is a work done, and this work done is equal to the stored potential energy U is equal to 1 by 4 pi epsilon 0 Q1 Q3 by R13 plus Q2 Q3 by R23. Now what you have to do means we have to put this as equation 4, equation 5, equation 5. Now the total electrostatic potential energy for this system, for this point charges, for all these three charges Q1, Q2, Q3, the total potential energy we can find out by adding the equation 4 and 5. So adding equation 4 and 5, we will get the total electrostatic potential energy. So that you can take U is equal to, add this equation 4 with this equation 5. So 1 by 4 pi epsilon 0 Q1 Q2 by R12, this is equation 4, plus equation 5, 1 by 4 pi epsilon 0 Q1 Q3 by R13 plus Q2 Q3 by R23. Now 1 by 4 pi epsilon 0, 1 by 4 epsilon 0 is common. Take it outside, 1 by 4 pi epsilon 0. So inside bracket what will be there? Q1 Q2 by R12 plus here Q1 Q3 by R13 plus Q2 Q3 by R23. So this is the total electrostatic stored potential energy, and you can go through this. If you want, you can take a screenshot of this page, this 2 page. You see, I'll show you. Take a screenshot of this 2 page, so that you will get the derivation. Okay, take the screenshot in the textbook. Those who have the textbook, you can refer page number 33. Page number 33, this one 1.5.6, and page number 34. You can see this full page. So you can take a screenshot of this and study. All of you take your notebook and study this. Prepare this, write in your notebook. Again I am saying, once you are coming to school, I will check everyone's notebook, so that you all should write all the derivation in a notebook. So thank you all. Bye bye. See you on the next class.